Maybe start with generative AI. It's, as you, I think, touched on, it's different from what we call traditional AI. And I also want to acknowledge the term traditional AI is very odd to say. It's not traditional. It's very much prevalent and relevant and active.
Welcome to the Modern.NET Show, formerly known as the .NET Core Podcast. We are the go-to podcast for all .NET developers worldwide. And I am your host, Jamie GaProgMan Taylor. In this episode, Amit Bahree joins us to talk about what generative AI is, what it isn't, and how it's different from so-called traditional AI. He also talks us through his new book, Generative AI in Action, a book that I had the good fortune to read ahead of publication and can definitely recommend. I also had to ask him the million-dollar question that has been on a lot of our minds since generative AI seemingly burst onto the scene out of nowhere in 2023. I'm not asking, is it going to replace an engineer? But no, can an engineer for now just ignore it a little bit?
No, it's not replacing any engineers, I can tell you that. No.
It's important to note that Amit and I recorded this conversation at the start of May 2024. Whilst there's very little that we talked about which was time-bound, there have been a few major announcements since the recording of this episode and it initially going live. Some of these announcements include the release of ChatGPT 4.0, that's ChatGPT's omni-modal model, you'll learn what that means in this episode, and Microsoft's small language model family Phi 3. Anyway, let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern.NET. So, Amit, welcome to the show. It has been a fantastic journey getting you on the show, and a very, very warm welcome to you. For those who don't know, Amit and I actually met in person in Seattle to discuss this. So that's pretty cool.
Hi, Jamie. Thank you for having me. I've been super excited and looking forward to this since we met a few weeks ago now.
Oh my goodness, it's more than a few weeks. It's we met sort of mid-March, I think, during MVP Summit.
Oh wow, okay, it has been a while
then. Yeah. So for the listeners, we're recording this on May 3rd, 2024. So the other thing as well is I'm actually going to lean on my editor a little bit, see if we can get this out pretty quick, only because the topic that we're talking about, I feel, is moving on really quickly, right? And I was hoping, I know you've got a book coming out. We can talk about that in a minute. I may ask you to do like an elevator pitch, just let the folks know a little bit about you. Mm-hmm. But we're going to be talking about generative AI and what it kind of means for developers, and maybe perhaps a little bit like a super basic entry level, what it is and how it works sort of thing. Because I know you've got the book that's just come out or will be coming out by hopefully in the near future when this episode drops. So I wonder, before we can get onto any of that, would you mind sort of introducing yourself to the listeners, maybe a bit of a elevator pitch, that kind of thing?
Yeah, absolutely. So again, thank you for having me. My name is Amit Bahree. I'm part of the Microsoft engineering team in what we call AI platform. It's the team that builds all the AI products that both ourselves, Microsoft uses, other product team uses, and of course, most importantly, our customers use. I'm responsible for a bunch of engineering on the platform, but at the same time, I'm also, it takes a village, and I'm one of the monkeys in the village. So, that's me at a high level.
Amazing. Cool. Okay. So we will be talking about generative AI. I know that a lot of the AI stuff is done traditionally in like Python and other languages. And I know that we're talking on the .NET stuff. Mm-hmm. But what I'm hoping is that we can talk about like what kind of things .NET devs might need to know in the coming months with the massive AI wave that's already happened and is continuing to happen.
Yeah.
But I guess before we do that, I know you have a new book coming out called Generative AI in Action. Mm-hmm. And I was wondering if you could give the listeners a bit of a let's have a talk about that. So so background for listeners, I've read most of it. I've read like an early access version, which was very kindly provided to me by Manning. I am going to be buying the book though, so and I recommend you all do too because it's really good. But with all that said, who is the target for the book, and what does it cover? I guess.
Yeah. So maybe I can perhaps, before I answer that, start why I did this, unless you're going to ask me that later. But so, maybe start with generative AI. It's, as you, I think, touched on, it's different from what we call traditional AI. And I also want to acknowledge the term traditional AI is very odd to say. It's not traditional. It's very much prevalent and relevant and active. The industry calls it traditional AI, and that's what we sort of have to snap into sort of that, vernacular. But having said that, it is the new form of generation where AI is generating things rather than interpreting things and giving you a yes or a no or a thumbs up or a thumbs down in the past. Of course, ChatGPT took over the world. As I sort of half joke, my mom's a ChatGPT expert, along with, I'm sure, many other folks' moms. But it certainly, took the world by storm. And that's really why a lot of where the genesis of the book came from, because, one of the privileges I have sitting in my role and in the team is sort of having a front seat with all the work we're doing with OpenAI and Azure OpenAI and our other AI products around this set of things. And primarily, in my role, I've probably talked to most of the Fortune 500 companies in the last 18 months. They're from CXOs down to, architects and leads and devs and whatnot. And everyone's taken by, what can we do? I think the part of it is the hype, because it went from like geeky science papers that a bunch of people would read, like me, to sort of, business news, to sort of front page news, and, folks are trying to figure out what to do or not. And when I was talking to all the people, I saw this pattern of questions and things coming back, and, what it should be, how do we do it? How do I start? Which is kind of what your question was, which I haven't answered. I'll come to that, I promise. And then I'm like, surely somebody's written a book about this who can help answer all of these questions again and again and again. And then clearly there wasn't at that point in time. So I figured I might as well do one. So that's sort of where it started. But in the end, it's about, for developers, you don't need to be the one of the beauties of generative AI is, a lot of it is around language right now. Of course, there's images and vision sort of things coming up. There's video, there's music, but primarily it is language, which is, where if you think of a large language model, which is one of the underpinnings, the likes of ChatGPT, you don't need to be a language expert to use them. You don't need to be a machine learning data science person to use them, which in the past you had to. You had to understand a whole bunch of terminology, special SDKs, Python packages, and this and that. The beauty of these things is it's wrapped up as an API. There's an SDK and number of languages, and any developer can just use the API and sort of inject this AI in whatever app they're building to make it better. And that fundamentally, in many ways, is sort of a democratizing from a developer's perspective, where, traditionally it was more machine learning, data science people, and now the trend we're starting to see is most developers, if they're not already, they need to start thinking about how do I become an AI developer, in the sense, how do I incorporate a bunch of this new AI, which is just an API call away or an SDK, install away. That was a long, rambling answer.
No, it was good. I really appreciate it, because sometimes you need the long answer. And you're absolutely right. I think I've been telling a bunch of developers that I know, hey, go get either Azure OpenAI or an OpenAI, throw $10 at it, get yourself an API key, and start you're just seeing what you can do with it. Because my experience of using, say, the ChatGPT/OpenAI API has literally been: I create a JSON object, I send it over. The JSON object includes my prompts, and it comes back with a number of responses. It is literally that simple. It is, that's like the hello world, right? But it is literally that simple to get started.
Yes. And the SDKs make it even simple. You don't even have to craft the JSON sort of, package, if you will. It's even simpler right now.
Okay. Yeah. So then, so what, as a developer, regardless of the technology I'm using, what am I going to get when I read the book? I'm going to get like an introduction to, am I getting? I feel like I'm cheating because I've read the book, right? But am I getting like the background information as to how generative AI works, or am I getting, hey, call this API to do this thing? Right. Like, what's the thing there?
Right. That's a great question. So the title sort of in some ways gives it away. It's an in-action book, so I don't go much into the theory and the genesis of things. It is more about the target audience, which was one of your questions earlier, was like it's primarily any developer or data scientist for that matter. However, it's mostly those who are in an enterprise setting. Large companies, enterprises, organizations who have a number of constraints and restrictions and so on. And the inaction part is, really many of them don't particularly care about the theory, so to speak. They want to, many of them, I presume, already understand at least to some degree. And it's more of like, okay, how do I use it? Because how do I, at my job, in my day, I have some work to be getting done. How do I incorporate this to get going? This is sort of an enabler. I'm actually going to use, and this is not me drinking the Kool-Aid necessarily, but Microsoft calls a bunch of this as co-pilots, and really the analogy there is it is your co-pilot, so it's helping you. So the inaction sort of goes back into that, like how can I get going and using it to solve whatever I'm trying to solve, and rather not get into the stuck with the tech itself, so to speak. So the book does start with a little bit of introduction on what is generative AI, what can it do, what can it not do, what are language models. There is new constructs because of these Gen AI things that most of us developers don't necessarily know. So this notion of embeddings, this notion of tokens, this notion of vectors and so on. So these are basic building blocks that one needs to understand to be able to go use these things. And that's what we sort of introduce on. And then we go in like building the basics on if you're generating text, what do you do? If you're generating images, what do you do? And so on. That's sort of the first part. And then we switch into sort of more, that's your foundation. Then we switch to more interesting sort of advanced use cases on things like, there's new constructs, something called prompt engineering. There's new constructs of something called RAG, retrieve augment generation. What is that? Why do I care? How should I use it? Then we get into more advanced techniques like model adaptation, which is like many people call it as fine tuning. How do I tweak the model? What's my new application architecture looking like? Which incorporates these. What are the things I should think about? How do I scale it up, my app, for production deployment? How do I do evaluations? And then finally, a lot around ethics and responsible AI, and showing you things like what are new threat vectors one has to think about. How do you sort of mitigate them? How do you approach it, and so on. So again, if I step back, if I'm in an enterprise things, it's all of these things I have to think about. But the fundamental I want to go back and remind your listeners is, in the end, it is adding and complementing what we as developers know. So things like distributed architecture, things like if I need to scale things out, things like best practices for development, for security, for deployment, none of those change. All of those are more relevant if, and then in those constructs, we're going to add a few new things, things like tokens and so on, I touched on, which you need to think about. So the mental analogy maybe for a little older listeners like me would be, it's almost like that shift when we went from sort of two-tier, three-tier, pre-web architecture to the web architecture. It doesn't mean everything we knew went out the door, but we had to think about new things in addition. That's sort of the shift, or for the matter, mobile phone applications. If you think about, form factors and flows and screens and so on, it didn't mean the previous things wasn't valid or relevant. You had to add new things to be cognizant of. It's the similar shift. Like there's new things you have to be cognizant of, but you're building on existing experience, knowledge, and best practices that one already has.
Sure. I there's a whole bunch of stuff that you'd said there, and I want to take some time just to unpack a number of them, especially when it comes to things like threat modeling, right? So we've seen it already. I think I want to say it was late last year. One of the Canadian airlines, they hooked up a version of ChatGPT to or it was reported as ChatGPT. I don't know whether it actually was, but it was a chatbot on their website, and someone was able to prompt engineer, I guess, their way into getting on a flight for free or getting a refund or something. And that's a user who came along and tried to chance something, right? And so that's something that I think that we're going to see a lot more of. And I know that whilst I was at MVP Summit this year in March, I'm not revealing anything that's covered under NDA for MVP Summit, by the way. There was a very public, what is it? Almost like a CVE, but it wasn't really a CVE. It was like, we've discovered this new threat. Whilst I was there, and it became really public. I want to say it was, is it Mark Russovit? I always mispronounce
Mark
his
Russ. You say Mark Russ.
Yeah, Mark Russ. He was the kind of the face of this piece of research that him and his team, or perhaps someone from your team, I'm not sure, had done, and said, hey, this is a new threat, you know? And I've seen ones where people will take ASCII art of the prompt they want to put into a GPT-like system, and it's able to understand the shape of the words in the ASCII art. And so I feel like, I don't want to scare people who are listening, but like this opens us up to a whole world of crazy attacks. And I just also, the idea of the co-pilot, I absolutely love that analogy because it is perfect for what it is, right? I'm going to use GitHub Copilot, right, as an example. So GitHub Copilot sits inside of my IDE and it's giving me information in the same way that an airline Copilot would give me information if I'm the pilot. I still need to make the decision. I still need to work on that. But the Copilot is feeding me that information, right?
That's right. I mean, it does, like the Copilot, just to riff on that, all of it needs to be anchored in use cases. But in that example that you're using of GitHub Copilot, and work closely with the GitHub team, it is doing a lot of the heavy lifting and the grunt work, and then easing you off that burden, allowing you the bandwidth and the time to go think about more interesting things around that, rather than, things like scaffolding code and API calls and so on, which are needed. And maybe when I was younger, I would be super interesting to me, maybe less so now. and then on your threat thing, I covered that, I think, in chapter 13. And it's that, a lot of it is cat and mouse as well now, because these are new areas of tech. There are people who are pushing and saying what is possible to break, what is not possible to break, where can it bend, where can it not bend. And then, equally, that's where the cat and mouse, you catch it, you catch some yourself. But, I go back to, it's like understanding the limitations of these, because they're not, despite all the hype, it's not magic and solving everything on the planet, unfortunately or fortunately. So understanding the limitations. And then that also then says, like, how do you implement it? Fundamentally, it is not much different than any other things you do. It's just more of understanding the attacks, understanding those threat vectors, and then figuring out how do we do. Your example of the Canadian airline, if I recall off the top of my head, I think it was more of getting a fare or a refund, which was more, the model was what we would call hallucinating. So it basically gave a answer back that it made up on its own as a policy, not really what the policy of the airline was. But since it was a formal, how do I put this? I'm not a lawyer, but since it was a formal sort of communication, or like it was a chatbot, it was their formal mechanics back to the customer, they had to go honor it. So the exact problem there is what we call is groundedness. So it wasn't grounded in like in-house information, i.e. it's their corporate policies on, or the airline's policies on refunds or whatever it was. So that's one of the things we touch across various chapters in the book on this concept of grounding, and then that's one of the evaluations and tests one should do around that to avoid something like this.
Welcome to RJJ Software's podcasting services, where your podcast becomes extraordinary. We take a different approach here, just like we do with our agile software projects. You see, when it comes to your podcast, we're not just your editors, we're your collaborators. We work with you to iterate toward your vision, just like we do in software development. We've partnered with clients like Andrew Dickinson and Steve Worthy, turning their podcasts into something truly special. Take, for example, the Dreamcast Years podcast's memorable goodbye episode. We mastered it and even authored it into CDs and mini discs, creating a unique physical release that left fans delighted. Steve Worthy, the mind behind Retail Leadership with Steve Worthy and Podcasters Live, believes that we've been instrumental in refining his podcast ideas. At RJJ Software, agility is at the core of our approach. It's about customer collaboration and responding to change. We find these principles most important when working on your podcasts. Flexibility in responding to changing ideas and vision is vital when crafting engaging content. Our services are tailored to your needs. From professional editing and mastering to full consultation on improving the quality and productivity of your podcast, we have you covered. We'll help you plan your show, suggest the best workflows, equipment and techniques, and even provide a clear cost breakdown. Our podcast creation consultation service ensures you're well prepared to present your ideas to decision makers. Our services help you reach your podcasting dreams. If you're ready to take your podcast to the next level, don't hesitate. Contact us at RJJ Software to explore how we can help you create the best possible podcast experience for your audience, elevate your brand, and unlock the vast potential in podcasting. Remember, with RJJ Software, your podcast becomes extraordinary.
Sure. Because I guess that I feel like I'm leaping across our questions list here, but I feel like that's something that, if somebody was to say to me, build me some software and write some tests for it, I know that the .NET code or the Python code or whatever that I'm writing for this maybe CRUD app is going to be deterministic. Every time that I push the button, it's going to do the exact same thing.
Yep.
But then we throw in generative AI.
Yep.
And I know from reading your book and from some background information I'd done previous to that, it's all probabilistic, right? So, like, how do I go about testing that? That's, again, it's that extra thing you've got to think about, right?
That's exactly right. I mean, these are non-deterministic. Now, you can nudge them closer to getting a similar answer. Sometimes you might get the same answer. Other times it will not be the same answer, but similar answers. And therein is also an interesting aspect is, there's a chapter also on like evaluations, because you can't, as you're touching on, it's not like a binary yes or no, did I get the same thing? Because you will most likely not. So part of this is understanding how do I do evaluations differently, and also benchmarks which go hand in hand, and what are the different techniques and ways to go do that. So that also becomes a very fascinating area and subject by itself.
100%, I agree.
And sorry, just one afterthought as I finished talking was, it's also, at least in the context of large companies and enterprises who are more used to determinism, right? Because they have regulatory reasons, policies reasons, legal reasons, and various others to have that absolute, the answer is always the same and correct, as we all expect. Our life will not work in many dimensions. I think some of it is also a mental shift that in some of these dimensions, the non-determinism is okay. And that's not, it's easy for me to say. In reality, that's a big mental shift for folks, and it's a journey. It doesn't happen overnight.
Absolutely. I guess there's going to be people listening in who are like, whoa, you're talking like really high topic, like enterprisey things, right? And I don't know the first thing about Gen AI. So for those folks who are listening in, I wonder, could we, if you don't mind, could we sort of look just a little bit under the covers?
Oh, absolutely.
I know that Scott Hanselman always says, let's look at the layer underneath, right? So let's pretend I've opened up ChatGPT, or maybe I've built a system that uses Azure OpenAI or OpenAI or whatever, and I'm using it in a chat-like situation. I'm going to give it a prompt. Maybe I'm going to ask it a question. What's actually happening with that prompt, right? I know you hinted at things like tokenization and vectorization and things like that earlier on. I just wonder if we could sort of take some of those ideas and just give the listeners an idea of what is actually happening there.
Sure. Jamie, that's a really interesting question. So the roots of these new Gen AI architectures are, the genesis of this paper from Google on attention is all you need. So what happens when you type in, let's say, hello world in ChatGPT? We just make it simple, just for our discussion. When you type in that text and sort of hit enter, the first thing that needs to happen is convert this text into a number representation. The way these models work is they understand tokens. So even though you're entering a prompt, which is a string, or a sentence or a question or what have you, the thing they understand is a token. So the way you want to think is you talk to them via tokens. And a token is basically a numerical representation, because at the end of the day, all the AI models are just matrix multiplications and long, floating point numbers. So the first thing we need to do is convert this text into what's called a token, which basically chunks it up into pieces. Depending on which model you use, its token will be different. So in the context of OpenAI or Azure OpenAI, roughly 3/4 of a word is one token. So if I put in hello world with a full stop or a period in the end, that will probably be 3 tokens, because the period itself is a token as well. These tokens are basically a number representation, which are called embeddings. That's how the model understands them. When you call in the API, you can go look at what an embedding looks like. It's a long array of floating point numbers. But the similarity of things is how the embedding is represented. And I can talk about that if you want. So the text gets converted into a token, which gets converted into an embedding, a number representation. And that then is what is passed on to the large language model, an LLM, to help sort of digest and understand what you're trying to do. And then once it digests that, it spits out an answer back. And then you sort of do a reverse. You get an answer back, you convert it, you get a string, you get an array of floating numbers. It gets converted back into a string representation, which then you see as generated, completed text on the output. So, if we look at it at a conceptual level, those are the steps. Text coming in, converts to tokens, converts to embeddings. You go through what's called an encoder and a decoder. These are the 2 steps of the model. And then out pops sort of a reverse, if you will, and then eventually text. What is important to understand, I think, to some degree, a large language model is a fancy autocomplete. its single purpose in life is to find the next word that it thinks is the right word. And if you don't tell it to stop in some manner, it'll just keep going, finding the next word and the next word and the next word, understanding the sentence, right? Understanding what you're trying to do. I think that's where, if you break it down to quite simply, like, its only single purpose is making you happy by giving you the next word that is meaningful in the context of the sentence. And you basically rinse and repeat, and then out pops a paragraph or a sentence and what have you. But that's all at a conceptual level, what happens when you sort of plug in Hello World into, let's say, ChatGPT.
Right. Okay. And so I happen to know then, because I've been playing around with the API, that obviously with OpenAI, I can get up to 5 different responses, right? So so when folks are telling me, oh well, if I'm only sending 4 tokens for Hello World, why am I looking at perhaps 200 tokens for the whole request? And I say to them, well, you send the 4 tokens, it generates the response. It uses tokens to generate that response, but there may also be a couple of other responses that come with it, right?
That's right. So you have options and parameters, which is what you're touching on, to tweak and say, generate up to a certain limit of responses. You can either say, give me all of them back, or you can also say, of these 5 in your example, give me the best one back. So you can say like best 1 of 5 kind of a thing. And then the other aspect on these, at least these LLMs, is I think this is where most developers who are new to this get somewhat confused in the early days. Because it's an API call, we expect it just like we would call another library, right? I call a function or a parameter, give it parameters, give it an input, out pops an output. It's doing some compute. And then I get the answer back to whatever I'm trying to do. In this case, there's 2 buckets of work that happens, and it is important to sort of disconnect the two, at least mentally. The first bucket of work is understanding the prompt. What are you asking? This is where this whole new techniques of prompt engineering are. So I'll use an example, which I think I used somewhere in the book. I can't recall off the top of my head. If I say, write a 3-verse poem on pandas, versus if I say, write a 3-page essay on pandas. Now, understanding my request, i.e. my input prompt, is the first bucket of work that has to happen. That uses separate, different tokens to understand, what I'm asking for. In my 2 examples, they're almost the same. They're, for all practical purposes, they're the same request going in the sense of tokens, the same compute needed to understand what I'm asking. But my second bucket of work is the generation. That in my 2 examples is completely different. And in both in terms of tokens and hence the amount of compute and ultimately cost. I mean, so a 3-verse poem of pandas, the amount it takes and the tokens it's going to use to generate is going to be very different than a 3-page essay on pandas. Even though my input was the same or very similar, my output is drastically different. So when you think about the notion of computational cost and actual cost, because tokens is the new currency in these new generative AI models, my input is about the same and the cost of processing the input is about the same, but my output is very, very different. So one has to be cognizant of both of these dimensions. But it also adds to other things like latency. So again, if I'm building, depending on my use case, I need to be aware how long would my generation be? What am I asking it to do? The more I'm asking it to do, the longer it'll take as well. So the earlier mentally one can break it up as processing the input and processing the output. Those are not formal terms. I think the easier the adoption and the mental leap for many developers who are new to this.
Sure. Yeah, I think the shift in thinking here is definitely one that takes a moment of reflection. when first dealing with generative AIs, especially if you're dealing with the APIs, because you're right. It's the cost of generating that response, and I do know, and this may be outside of the scope of our conversation, but I do know that when I put in a request, I can get multiple responses back, and they could be filtered out or whatever. And like you said, it's about picking the one that fits the request best, right? So let's stick with ChatGPT as our example. There is some code in the ChatGPT front end that is going to when it sends a request over to the presumably OpenAI API, when it gets the responses back, it's going to go, right, okay, so this response has, I don't know, I'm making up a name here, but like a weight of 0.2. This one has a weight of 0.6. I'll choose the 0.6 one because perhaps that's what, that's what fits my request better. And I think that's worth knowing as well for developers.
That's right.
I'm using the wrong words there.
No, yeah. It's a probability.
There's some processing that goes on.
Yeah, it's a probability distribution. So again, if you go back to my thing, like, the single purpose of an LLM is to predict the next word, and that's its happy place. How does it do that, right? So that's where this concept of vectors come in. So when the vectors in what we would call is a multi-dimensional space. Now, we as humans are used to 3D. We think we know 4D. Maybe some do, but our brains beyond that can't comprehend. These state spaces are, I think, the OpenAI model says 1,536 dimensions, if I recall off the top of my head.
Wow.
So basically what the embeddings, the numbers, which is, floating points, numbers at the end of the day, what they do is, if you think 3D, but if you think 1,500 times more, these numbers get plotted there, and the distance between, and the numbers are representing, like I said, loosely speaking, a word. Like, it's not a word because it's 3/4 of a word, like I said earlier. But just to keep it simple, let's say it's representing a word. The relationship of the words and the meaning of the words are plotted in this multi-dimension space, and how close they are, the angle between them, the distance between them is really how they get the meaning. So when you and I have this example in the book. So when it says the dog sat on the next word most people would go is mat, perhaps, right? But you can actually look at the probability distribution. The model will also think like sat on the couch, sat on the floor, sat on a chair. So all of these are valid, but in this multi-dimension space, most of the times it's like sat on the mat or the cat sat on the mat. The mat is the highest probability distribution. So it's like most likely that's what you want. So that's what you get. But you can, using the APIs, actually, even in ChatGPT itself, and just on the web app, you can go and see what were the other options one has and what was the probability distribution of the other options as well. But in the end, it is just a probability distribution, but it is not doing it by itself. So the dog sat on the mat. It's not just looking at mat, the word mat itself. It's looking mat in the context of the whole sentence and understanding the meaning of the sentence, which is where the paper, which originally was attention is all you need, the concept of attention comes in. If I make it real with another example, which is one of my pet examples I use with many of our customers, is like the word bank. Now, if I use a traditional search engine where it's just doing a regular search, like a keyword search, right? If you search on bank, it's going to give you a list of documents or links and saying, here's all the places I found bank, the literal. But the notion of these vectors and the similarity thing I touched on is it takes into context. So if Jamie is in finance, maybe Jamie works for a bank or for a financial institution, and when you say the word when you say the word bank, it'll understand you're talking the bank as in the Bank of England or one of the other banks, as opposed to, let's say, the bank of a river, or if you're a F1 fan, the bank of a racetrack. Now, those three banks in the ones I said are fundamentally very different meaning, even though they are if literally they are the same thing, but the meaning is very different. So when you're thinking of in these multi-dimension spaces of these embeddings, and I was saying, their angles and the distance gives you the intent of the meaning, this is where it's picking it up. So Jamie works for the bank is very different than Jamie likes to have lunch on the bank of a river. Maybe you do, maybe you don't. but the intent of that bank and the meaning of that bank is how basically gets represented as these probability distributions in the context of the sentence.
Right. It's you said when you said how many dimensions OpenAI used, and you're right. I think in 3 dimensions. I don't think I can think in 4 dimensions. And then you're saying, I think I brought it down as 1536, which might not be the correct number that you said, but that's what I wrote down. And I was like, that's a lot of dimensions. Well, I don't have to do that math.
But the beauty of this is most of us don't really have to worry about this. We can just use the models. We can say, look, give me the top 5 probability of the next word. If I choose to do that, I can inspect it as the human and say, yeah, that one's better. No, this one's not better. And then there's other sort of a little more advanced parameters in the API. I can go and nudge it. So if I'm going to pick on you again, Jamie, sorry. But if Jamie doesn't like the word bank for whatever reasons, he's had not a great experience at the bank of the river he was having, a picnic at. And Jamie can go and say, never ever generate the word bank for me. So you can actually, in a way, force it to say, if you see that in your generation, please delete that, loosely speaking, and replace it with something else. So there's sort of more advanced parameters you could nudge and control the generation back should one need to.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. Sure, that makes sense. And I guess I'm going to ask, so we've been talking about large language models so far. Yep. And I know that a few weeks before we recorded, there was this announcement of Phi 3, which is the latest in a family of small language models. So I wonder, could you speak really quickly to the difference between a large language model and a small language model, other than like just the name? Like, is it quite literally just a smaller version? Like,
so the underpinnings are the same. What we've been touching on, and the stuff we've been talking about is fairly high level right now. Like, so a small language model has the same thing. This concept of tokens, embeddings. It may have an encoder or a decoder part within the model, and it's doing generations back. So fundamentally, architecture. When I say architecture, I mean model architecture. It's basically the same construct. The main difference really is literally in the name. It's small in relation to the large. So this is one of the other conversations I've been having with many of our customers. It's not when you compare it to a large language model. So let me back up for a second. One way in the industry we measure sort of the power and also the complexity of these models is how many parameters a model has, which in the end is, as we touched on, All of these AI models are, at the end of the day, non-deterministic. And the way it figures out is different layers and different knobs and what have you. So the number of parameters are the number of knobs it can tweak to go perform what it's trying to do. So the large language models are like, trillion plus parameters now. That's, like I said, the parameter count is a measure of the power of the models, i.e. how sophisticated they are, and also the complexity of the models. Of course, the larger the model, i.e. the more parameters, and this is where laws of physics and computer science doesn't change. I need more compute. I need more GPUs. I need more memory. I need more bandwidth. So bigger doesn't necessarily mean better per se. So therein is where the small language model comes. Now they're small in relation to the large, but by themselves, they're still pretty large. So for example, Phi 3, in fact, we announced that last week now. We announced Phi 2 a few weeks ago, what you were touching on. Phi 3 comes in a family of sizes. The smallest is Phi 3 Mini, which is the one we announced, and builds coming around the corner, and I'll just say only that. But Phi 3 is 3.8 billion parameters. Now, 3.8 billion parameters by any stretch of the imagination of computer science is not small. It is pretty complex. But when you look at, which is like hundreds of billions of parameters, in relation to that, it is small. So I think that's the first thing, because people often have this incorrect notion that, small means I can deploy it in sensors and I can run it on my phone. We showed how you can run Phi 3 on the phone, yes. But can you run it at production at a certain scale where it'll work, meeting your users' needs is a different conversation. So relationship to the large, it's small, but by themselves they're fairly complex. But then the other, so that's once on the size. But the thing they offer is, because they're smaller, they're quicker, i.e. latency is lower. I don't need as much computational things. I can actually run them on a CPU if I need to, rather than a GPU, or I can run them on a smaller set of GPUs or smaller amount of memory. So what folks need to probably think about is, I use this car analogy, right? So if you think of like a frontier model, as we call it, like a GPT-4, if you think of that as a Ferrari, and if you think of a Phi 3 as a small language model like a Fiat, there are times where you need a Ferrari, but if you're stuck in traffic or what have you, there's times where actually a Fiat would make more sense. So it's not that one is better than the other. It's more like, what is the use case? What are you trying to think and what are you doing? And that for that point in time, use the right model. So that's how you want to think about it. The capabilities are lesser because they're smaller, but they're also then quicker and faster and cheaper to run.
Right, okay. And then I suppose, okay, so in a situation where perhaps I don't need to use a large language model because maybe I don't have the massive amount of compute required, the hardware required, I could perhaps say, hey, for this particular task, I'm going to shift over and use my small language model because maybe I can run it locally. Like you said, I can run it on a CPU rather than on a bank of GPUs. Or perhaps I don't need to get specialist hardware, or maybe we're in a constrained environment, right? Maybe, here we go. Right. Oh my goodness. Scalable microservices based AI. Okay. So we've got the central LLM on a server somewhere, right?
Yes.
That when I'm sitting in the office and I've got a stable internet connection, I can be connecting to that and having that help me do my work. But then maybe when I go out into the field, I don't have a stable internet connection. The app that I'm running that is connecting to the LLM could perhaps detect that and go, hey, right, I'm going to switch over to the SLM now because it's running locally, and I can do some of this processing. And then when we get back to the office and we've got a stable internet connection, I can actually shift over to the LLM and maybe do some eval work, or maybe get you a better answer. But the best answer I can give you right now is based on using the small language model, which is running locally. Here's what it says, right?
That's 100% great. I'll actually even push you more in a way. It doesn't even have to be whether it's a stable connection or if I'm out in the field in sort of a disconnected or semi-disconnected sort of mode. the beauty of these LLMs and SLMs and Gen AI is it's an API call. So when you're building your application, it doesn't mean a mobile app, but a web app, an enterprise app, or whatever you're building. It's an API call. It's not like, for example, like the CLR. It's not that I have this dependency on a certain version and I'm stuck with that dependency for good or for bad for my whole application, because these are stateless APIs. So the way we suggest, and I touch on this in the book as well, is when you're building your application, because it's an API call and they're stateless, you use the right model at the right step in the time. So in the same workflow, you should be able to, and you should absolutely think about using multiple models for their power that they are. So for example, if my use case is, let's say, summarization, I have, which actually a lot of our financial companies, a lot of the banks are using it. There's a lot of finance long-winded documents which are needed to be summarized for various reasons. I can talk about those, but I won't necessarily get into them. To understand, for example, if my workflow is summarize these documents at the close of a trading business day, right? And I got to summarize it, have a point of view within, let's say, my financial institution before markets open the next morning. Until now, one had to, like a human would go sit and read through, summarize it, what's happening in which industry or which company and what have you. Now you can have an app as a co-pilot, which is doing that grunt work, summarizing it and giving you sort of the TLDR or the summaries, right? Here's the key points. Now, if I need to understand what type of a document it is, let's say, or which industry is it, because I have experts. Maybe Jamie is an expert in, computing industry, but Amit's an expert in agriculture. By the way, I have no idea about agriculture. You could use a small language model because it doesn't need to go comprehend the whole document. It needs to know enough that, like, hey, is this financial related? If it is, then I'm going to go punt it to Jamie. Versus this is agriculture related, I'm going to go punt it to Amit. So you don't need a large language model and all the horsepower and the power it has to go do that. You can use a small language model. Now, once you get it to the right place in the right workflow, then you can bring in the large language model. And in the end, you're saving cost because, a large language model is more complex, more costly to run, more tokens it's using. So it's not only your disconnected, semi-connected scenario, which is 100% accurate, but it's also use the right model for the right capability at the right step in the same application.
Right. Okay. Yeah. So I could have a small language model that I say, hey, tell me what this document is. Mm-hmm. Like based on pages 1 and 2, what kind of document is it? And then it will come back with, it's a 90% probability. It's like you said, a financial document.
Right.
Okay, cool. So then my app would say, right, okay, you've come back 90% positive. It's a financial document. Like you said, I'll go push it to the large language model that is trained on finance stuff. Yep. And have it do that rather than have the large language model that is trained on finance stuff waste time in case it's a document about mechanics or engineering, right?
Yeah, I mean, and it's also efficiency and optimization. So like, most applications have an orchestrator, right? And then in your orchestrator, in your workflow, it would be using a bunch of these models to go figure out which way do I punt it, right? It's a fancy traffic cop at the end of the day.
Mm-hmm. Okay. That's really cool. I hadn't even thought of that. Like most of my ideas around Gen AI have been, hey, summarize this, or can you create me a thing that does this? But like having something that can help make those decisions mm-hmm. as to where to process, how to process. Mm-hmm.
I mean, really cool. Like in GitHub Copilot, for example, it's a bunch of this stuff running as well. Like, do I have different models which understands a certain programming language or a certain package or a certain library to help me write code better? In some cases, for example, latency and all doesn't matter. In other cases, it matters. So I think what many people need to step back and think about, like, what's the problem I'm solving? What's the use case? What's the task at hand? And then go like, okay, right, now that I understand what we're trying to solve for, what do I go pull in? I think many of us, including me, have been guilty of like, I have GPT-3 or 4 or your next thing, and I'm going to go use it everywhere. And I'm like, no, maybe. So switch it on its head. Start with the use case. And in the use case, what all can I use? As long as it's language related in our examples, right? I mean, yes, there's image models as well, but like code, we touched on GitHub Copilot, for example. Code is language. It's a different language, but it's a language. So, you are also in the constraints of a language model. I think that's also have to sometimes go remind people. They're like, can it go predict the future? I'm like, no, it's a language model.
No, that's fantastic. Okay, so we're running a little low on time, and I have a number of hopefully shorter questions from the community. Some wonderful folks over on a Slack group that I'm part of for the Coding Blocks podcast have sent in some questions, and I wonder if we could run through those, a few of those, if that's okay.
Yeah, absolutely.
Oh, excellent. Okay, so user Ronald over there has asked, in your opinion, is it now urgent for developers to start learning about generative AI and LLMs, or AI in general, like the generative AI in general? Or is it something that they can just sort of ignore for a little while because things are moving so quick and focus on non-AI tech tools to help them learn? And will they still be okay, do you think, in their careers in 6 months' time? I'm not asking, is it going to replace an engineer? But can an engineer for now just ignore it a little bit?
No, it's not replacing any engineers, I can tell you that. No, I don't think it'll be, from a career perspective, helpful to ignore it. I would say, because the basic, as much as there is new models coming out and the hype and the speed of which is tremendous, the underlying constructs and the principles are so far the same. The things we touched on, embeddings and how they work and tokens and so on and so forth. I won't, if I was them, I won't ignore it. I would understand how they work at a high level, understand how can I use them in my use cases. And don't have to get into the weeds of the tech itself. I mean, that's the beauty. It's an API call. So understanding the power of them and being aware of what's happening in the industry, I think would be beneficial from their career perspective, because this is not one of those you can, like other places you can leapfrog a tech, right? You can like ignore a bunch and just leapfrog to like this will not be one of those as we are seeing right now.
Right. Okay. It makes sense, right? So I've been telling people it's like the pocket calculator, but my friend Jim said something that's even better, right? So I said it's a bit like the pocket calculator. When the pocket calculator came out, all of the engineers and scientists who weren't using it were operating at a less productive state than the engineers and scientists who were using it. He said, let me take it one step further. It's a bit like the spreadsheet, like a spreadsheet application. Before things like Excel and other spreadsheet apps, it would be expensive to hire someone to pull out a physical ledger and write out all of the things that needed to be accounted for. Whereas when Excel and things like that came along, you had to within a certain constraints, near infinite amount of space to actually write out whatever it is that you're writing out, and to have it help you do those calculations, which meant that more people could afford to have accountants and more people could afford to put things into spreadsheets to help them visualize that data.
That's right.
And I think you're right. I think it's definitely not going away. It's something we definitely need.
No.
Right. Okay. And speaking of Jim, he's actually asked. So Jim is one of these. Jim is brilliant. He's a retiree, but he's very much in the still interested in technology and still does a lot of stuff with development.
That's awesome.
And he's asking, how dangerous is it, or is it even dangerous? How dangerous is it to use Gen AI to generate both code and tests? Both could be hallucinating in a way that their issues cancel each other out. Shouldn't code or test always be created by hand, or at least be reviewed by human eyes? Do we trust but verify?
I would say the latter. Like, so, trust but verify, and the human's always in sort of command, if you will. That's why as we touched on the Copilot 2-3 times as we've been chatting. I mean, so couple of things. For example, there is a lot of value for Gen AI to build code, specifically when it is, a lot of scaffolding. I touched on that. So, there's a lot of bootstrapping code, which is fundamentally needed, different packages, different libraries, hooking things up, and so on and so forth. It's not solving the business problem, so to speak, but it is necessary sort of tax. We can't get away from it. So a bunch of that stuff, absolutely the machine, so to speak, should create it. You check it, validate it, and then leaving you time to go do like the more business problem in the code to go solve for. So I don't think in principle there's an issue that it's harmful, but the premise there, of course, is you should always, trust but verify. The one other thing, it's not a plug, but just because, some folks may not understand, like at least in the context of GitHub Copilot, like when we generate the code, and actually even on Azure OpenAI, when you get a response back, whether it's a code or not, it's not the raw output that you're getting back. It actually goes through a bunch of other checks and balances to make sure it is okay. Of course, it's not perfect, but there's an ensemble of other machine learning models it's going through to make sure it's okay, and we're not, writing, for example, security defects, and at least the known one. Now we can't capture everything because that in general is also a cat and a mouse. But the known security practices, for example, in code or in the context of generation of text, like let's say from OpenAI or Azure OpenAI, it goes through this content filtering and harms detection and so on and so forth. And so there's other AI helping this as it's coming back. So it's not completely just raw, if you will.
Sure. I think it also bears repeating something that we said when we sort of first met for that coffee in downtown Seattle was a lot of people may not realize, but they've been using AI for a long time, right?
Indeed.
A lot of the apps and services kind of use AI anyway, like Google search, perhaps Bing is using it too.
Yep.
I'm not asking for the secret sauce here, but like those search results that we're used to seeing, there's probably some decision making going on in there that's using context about who it is that's searching, or maybe the location they're searching in, and that's like an intelligent context injected into the search results, right?
That's right. And so you 100% like Bing uses AI, Google uses AI, a bunch of other stuff use AI. The thing in those also, and this is where like the Copilot analogy comes even more sort of in the forefront, we call them those AI on autopilot, in the sense, so if I'm searching or you're searching, we have no say in what and how it should search, right? There's no knobs we can tweak. We're not in control. It spits out something, and that's what we have to sort of use. Well, we can choose not to use it, but that's what we get. Whereas in the Copilot, you are in charge. So there's knobs and tweaks you can do. It's not forcing like, hey, this is the way. You can see and understand what's happening. So it is your Copilot. It is helping you at the individual, but ultimately you are the one who's deciding it, not the algorithm or the AI is deciding as the other one. So all the more reason it empowers you more to know what is right or wrong, because we only as humans understand that, right? These things don't.
Sure. And you're absolutely right there. Like the more information that I can be provided when I'm using a system by the system, the better. GitHub Copilot, I believe there are other Copilots as well. So like other offerings and stuff. And I suppose there are other suppliers of AI, generative AI stuff, right? I know I'm talking to you and you work for Microsoft, but I just wanted to point out to folks that there are other companies as well, but obviously definitely check out OpenAI and Azure AI, right?
Yeah, that's right. I mean, we're not the only game in town for sure.
Cool. No, that's amazing. So I guess as we come to wrap up then, would you mind reminding folks about the book? And then maybe if there's a way to get in touch with you, if they have any questions, is it possible to get in touch with you? I mean, maybe you don't want people asking you questions.
Yeah, so the book's again from publishing by Manning. It's called Gen AI in Action. It should be out soon. I'm finished with it. They're going through the final checks and whatnot. And I think all of us are keen to get it out as soon as possible, because I'll have to keep editing and updating the thing as quickly as the world's moving in the context of AI. So please do go check it out. Getting in touch with me is quite simple. I'm on Twitter, my last name @Bahree. I have a blog which is more for me. It's my brain dump. So if you go, and maybe Jamie in the show notes, you can put that if you want. But it's blog.daisygeek.com. I can email you that later as well. So there's a bunch of ways folks can get in touch with me if they want to. Equally, if they want to keep away and say I have nothing to do with this person, I won't blame them either.
Oh my goodness, amazing. Well, Amit, it's been wonderful chatting with you today, and thank you ever so much for being on the show and helping folks to sort of get an idea of what's going on with AI. And then hopefully, they'll go buy your book and learn a whole bunch more. I know personally, I've read the book and I know that it's going to be useful for almost every developer I know out there who's interested in this stuff. It reads very much as a let's gently introduce you to some stuff. It's not like AI is going to rule the world or anything like that, which is what I've read from some of the more civilian authors, shall we say, on AI.
I appreciate it. Thank you for having me. It's been great fun, and happy to answer questions as folks may come.
Amazing. Thank you. Thank you for listening to this episode of the Modern.NET Show with me, Jamie Taylor. I'd like to thank this episode's guest, Amit Bahree, for graciously sharing his time, expertise, and knowledge. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at the podcast's website, that's .NETCore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .NETCore.show/review for ways to do that. Reach out via our contact page at .NETCore.show/contact. Or join our Discord server at .NETCore.show/discord, all of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope I'll see you again next time for some more .NET goodness. See you all again real soon. See you later, folks.